Hello everyone, welcome to Supply Chain Way. So today's topic we are going to discuss about prioritization. Okay, so specifically before we get into how we can do a prioritization in supply chain, let's first see why we need to prioritize and how do we prioritize. I think we'll just look at in general what you mean by prioritization, why we have to do it and how we can do it. So before getting into the business side of it, let me take a very day-to-day personal example. Okay, so assume you are on a weekday, Saturday, your best friend's birthday has been planned out in a very grand way and you are going to attend it. Let's say it is planned say by around in the morning, say 10 a.m. and suddenly you got into some family emergency, someone is very sick and you need to go and see them. This happened right a day before your best friend's birthday party. Now here you won't be able to take care of both of these. You won't be able to attend the party as well as take care of someone, a loved one who's very close to you. So here you need to prioritize one over the above, right? So the same situation can happen in a business as well, wherein you won't be able to attend everything, and you need to prioritize. And second one, how do we prioritize? When you are doing it on the personal standpoint, it is more based on emotions and the people involved, right? Obviously, the example what I have said, obviously you need to attend your loved one and there is an emergency. Obviously you need to talk to your friend and explain him and you need to attend that. As similar way, on the business, it is never an emotional or a people dependent decision. More it is a data backed up decision based on which you will be deciding which is the priority. And to be very specific, that is depends on how much time is available, what kind of cost is involved, and what is the kind of business impact we are talking about. So on a very high level, this is what we um, would take as a parameters to prioritize something. So this is overall in terms of the basics in terms of prioritization. Okay, now if you get into a little more, now there are multiple tools available within supply chain where you need to do a prioritization. You need definitely some support of tools. So in this complete series, we will be discussing different tools which is used in supply chain, but today we are going to discuss in detail about the most used prioritization tool in supply chain, which is nothing but the Pareto chart. It is also based on the 80-20 rule, which is many people call it as an 80-20 chart as well. Okay, so we are going to learn about what is this Pareto chart, and not just that, we will also see at the second half of this video, we will look at a practical example of how to use a Pareto chart, where I'm going to pick two exercises and I'm going to demonstrate that to you in Excel. Very simple exercises, but that would give you a flavor of how we can use a Pareto chart. And then I'll also talk about some of the use cases. Okay, it's going to be definitely a longer video because all these tools related videos would be longer, typically somewhere between 15 to 30 minutes, because this is going to not just explain the concept, but we are also do some examples together. Okay, so let's get it started. So as I've told you, Pareto chart is based on Pareto Principle, which states that 20% of the problems have 80% of the impact. Okay, so what that means is you're doing a project and you come up with a list of problems, a part of whatever the area you're working on, out of which just 20% of the problems are the vital few and the remaining problems are trivial many. Like that means the impact created by just this 20% of all the problems you have identified has a very significant impact on the business. I think that is what specifically the crux of a Pareto principle. And then using a Pareto chart, you can identify those fewer problems which I told you, which has the bigger impact on the business. Why we do that? Again, so that you can prioritize them and you can put all the effort, right, and focus on those selected few problems and fix them rather than chasing all the problems you have identified. Okay, the second important help which Pareto chart provides is to sequence the problems based on impact. Assume you have 10 different problems, right? You can also sequence them in an order based on the impact it has on the business. The last one, you can also prioritize based on the available data and not by perception or intuition. So as I've told you, the example, the personal side as a business side. In business side, you can never take any decision based on perception. It should be based on data. Okay, so that's the basics on what is a Pareto chart and how to construct a Pareto chart. First, I will explain the steps to you, but as I've told you, sometimes it may be a little bit confusing. After I explain how to construct, I'll also pick up an example and show you exactly in a spreadsheet how you can construct a Pareto chart. Step number one, you need to identify the data heads or categories in a particular process. So before even you start your data collection, it is very important you take a decision on the data heads. You should also decide the time interval, right, in which you are going to collect the data. Once you have this, go to the field or go to the systems involved, collect the data, and you need to build a data table which has the columns like what are the data heads and what is the value or the occurrence depending on what kind of data sets we are talking about. Third one, you are going to sort those values or occurrence in the descending order. The highest contributors comes on the top and then slowly the lower contributions come down to it. So basically the last lines would be the least contributing data heads. Once you sorted it, you are going to calculate the cumulative value by adding the value of each data head to that of any preceding data head. So it is a cumulative value. Again, I will be demonstrating this in Excel with a small example. So once you have the cumulative value, you go ahead and calculate the cumulative value percentage. So each value you are going to take that as a percentage to the total of the cumulative value, which would give you a percentage. So this all will construct in the same data table what I have said in the point number 1 and 2, and then you will plot the Pareto chart. So once you plot the Pareto chart, I will explain you which is those the 20% which has the most impact on the business versus the trivial many, which is the rest of the things which has the least impact on the business. Okay, so pretty simple, as you can see here, just 6 steps to do it. But what I'm going to do now is pick up a data set, so and then we will do a Pareto chart together. So probably you can quickly open up a spreadsheet, and both of this analysis, the spreadsheets can be downloaded just in the description of this video. I have just given the links, or you can just look at the screen and type these values. Either case, whichever is comfortable for you, you can do that. At a high level, it is going to take around 20 minutes to complete this exercise. Out of the cost analysis and problem analysis, I am going to pick one, which is the probably the problem analysis I'll take as an example, and we will solve it now. So over to the dataset problem analysis in Excel, and we will solve it now. Okay, so here it is. So this is the dataset what we have for problem analysis, just the replica of what I've shown on the PPT. Probably I will make it a little bit bigger. So what I'm going to also do is just remove the total because we are going to just put a filter. So I'll just delete it. So what we have here is a list of defects and also occurrence of the defects. Okay, so just by looking at the data set, what we can very fairly say is we are using a Pareto chart to analyze a list of defects by category. So the data heads are defect categories, and for each of those defect category, what is the occurrence for the time interval. Okay, again, we are not going to get into the details of what time occurrence and everything. So this is the data set what we have. So as I've told you in the steps, first and foremost thing, just apply the filters as I have done here. Go here and make this to largest to smallest. So you can see here the die mark and stain or the top 2 contributors, and then slowly the snag and slubs and knot are the least contributors. So just do a descending order. Now you create the additional fields which are required. The first field which is required is cumulative addition, which is cumulative sum, I'll call it. And then you'll also have to arrive at cumulative sums percentage. Okay, probably I will just make the same formatting. Okay, I'm just using a paintbrush to just do it. So all we have done is we have put the data into the occurrence onto the descending order, and I've also created 2 new columns, cumulative sum and cumulative sum percentage. So now I'll show you how to do that. So as I have explained you on the steps, you need to first add in. So first row, there is no preceding value, so it remains the same. And now I am going to add the occurrence for stain, which is in B4, plus whatever is the previous cumulative sum. Okay, so I'm just adding it. So B4 plus C3, and all you need to do is now copy this and then paste it till down. So what happens at each step, as you can see here, over here, each and every data head's occurrence is added with the previous cumulative sum, and that keeps going. So the total comes to 50,840, which is the total occurrence. So if you add the total occurrence also, you will get the same value. Okay, now all you need to go here is arrive at the cumulative sum percentage. So to arrive at that, what I'm going to do is equals. So what is the contribution of 9250 to the total, right? So 9250 divided by the total, which is nothing but 50,840. The same thing you need to do it for rest of the rows. I'll also convert this into percentage. I'm going to just make this as a static denominator for everything, because that 50,840 is going to be common for everything. So all we need to do is keep the cursor near to C14 and hit function F4. You will get it. Again, it's not an Excel class, but I just explain whatever I'm doing, so that if someone who's really new, you will understand what I'm doing. Okay, so the experienced people who are looking at it, please bear with me for that. So 18%. Now all I'm going to do is drag till the down. Obviously the end one you should get 100%. So there it is. You have completed the cumulative sum percentage. All you need to do now is construct the Pareto chart. To do that, select the defect category, occurrence, and click on control and select the third one, which is cumulative sum percentage. Okay, so these are the 3 we need: the defect category, occurrence, and cumulative sum percentage. Go to insert and probably click on recommended charts. All I want you to do is pick up a plain clustered column chart. Okay, that is the name, clustered column. Just click OK. You will get a graph like this. Okay, probably I will zoom in a little bit more on this area so that you will understand what I'm doing here. So this is very simple. The x-axis you get all the defect categories, and y-axis as occurrence as well as the cumulative sum percentage. So now all we need to do here is, as you can see here, the cumulative sum percentage is not visible because that is in percentage. That's in a completely different unit of measure itself. So right click, go to change series chart type, and within that, can you see here, cumulative sum percentage, it's in a clustered column. Convert that into a line graph, number 1. Okay, convert that into a line graph. Also make it into a secondary axis. Okay, and you click OK. And now you have constructed a Pareto chart. Do whatever formatting changes you require. Like for example, if you want to change the chart title, you can do that, defect Pareto chart, or whatever suits your project, you can do it. Then all the formatting, make the font smaller or bigger. If you want to change the design, you can do it. As you can see here, chart designs, if you want to change colors, all those things, I'm not going to get into the details. So now you have constructed your first Pareto chart for the data sets which is provided, which is nothing but for the defects. Now what I'm going to explain you is how to read this. If you recollect back, we have talked about Pareto chart, we talked about the 20-80 rule. not necessarily every time 20% of those defects contribute for 80% of the problem. It won't happen the same way. It could be 30-70, it could be 40-60. Okay, it is kind of a very thumb rule saying this 20-80 rule will apply in most of the scenario. Now look at this graph. Okay, the graph is very evident. So what it is showing here, I'll just mark it for you. Where find the position where the graph's slope is completely dying out. Just look here. This is the place where this has a very good slope and then it started to incline. Basically, the impact has gone really bad. Initially, the impact is really high. So what that means is all whatever to this side, these are all the defects which has a significant impact on the business because they have the most occurrence. Okay, purely by the data set. So when I have significant impact, we are talking about only occurrence. In case if you want to go still more and because of this occurrence, what is the kind of money I am losing? Probably cost of poor quality. Then you need to build the data sets by defect categories and also what is the kind of money you have spent or lost due to cost of poor quality. You can do that as well. In this example, this is purely by the occurrence. So what that means is all this dye mark, stain, crease mark, bowing and skewing, all these things contribute the maximum. Now what percentage is that? So now read it now. So 1, 2, 3, 4, 5. This 5 contribute to close to almost 85% of the total defects which is occurring is contributed by just these 5 different defect categories. Okay, so this is the way you need to read a Pareto chart. You can read it here or you can even go to the right hand side and you can read it. See here, you have see the percentage here. Just look here. So 18, 36, 54, 72, 88. This is where it is. Actually, the slope is dying down. So these are the 5 ones which is 5 defect categories contributing to the maximum of the defects. That is the inference from this data, which is close to 88%. To make it still more very specific. So totally how many defect categories are there? So you have 12 defect categories, and how many are relates to 88% of total is 5. Okay, so that means 5 divided by 12. Around 41.6% of the defect categories contribute for 88% of the total defects what you have measured or collected as a data. So this is the exact way how you need to read a Pareto chart. Okay, now back to the slides. I have few more things to share and then we'll be able to wind up this session. So we have completed this exercise, which is this problem analysis, cost analysis. Now again, please download the data, try it. In case you are stuck somewhere, redo those videos, recheck those videos, and then you try and solve it on your own. But still, if you have some questions, please feel free to put it on the comment, and definitely I will try my best to help you out on that one. Okay, so the cost analysis, please download the data sets and try it on your own. Now let's go back and see what are the different shapes of Pareto chart you will encounter, okay, in real life scenario, because what I have shown is an example. In the example, I have intentionally created a deviation wherein that just the 5 defect categories contributing for more, but in real life you could typically see different types of Pareto chart. So let's see one by one. So the most common type of Pareto chart, what you can see, provided your data has some a significant difference in significance of impact within those categories, typically you will get a graph like this, or you will get a graph like this. What is the difference between these two graphs? Okay, see this case, the first one. So let's consider this as the first one, this as the second one. On the first one, you have the significant categories are very low and they contribute to the maximum of the impact. So here it is very good for prioritization. You can pick very handful of prioritized items and achieve maximum within what your project is trying to achieve. How good is that? In this case, you won't be able to do that. Probably you have to take it to almost up to 50% or more to achieve what is required. Okay, so this is definitely good. The first one is really good because you can do really prioritization, handpick few things and then move forward. Many cases Pareto would be one great lever where we can identify quick wins within the project, wherein you identify 100 items, but you pick only 5 actionable items which given you 80% of what your entire project wanted to achieve, right? So those kind of direction you can take from a Pareto chart. Now the third one which I'm going to talk about is very, very important, where at the end of the Pareto chart, you say, you know what, I won't be able to prioritize because every defect category or every data category is contributing equal to the overall impact on business. So in that case, we call it as a flat Pareto, and this will be something like this. Okay, very rare. Okay, in my 20 years of using Pareto chart as one of the prioritization tool, I have never encountered something so straight like this. Yes, I have encountered this, I've encountered this, but never a flat. But you could come up with a data set which gives you a flat Pareto like this. In this case, what that means is it's absolutely every data head what you have is contributing a same amount to the business. In this case, so what you could not do, based on that data set, you won't be able to decide which one you can prioritize. So I'll give you an example. So don't think that okay, that is the end of it, you won't be able to prioritize. So let's take the same example of the defects and occurrence. So you're doing a defects and occurrence, and every defect is occurring the same way. Assume there are 10 defects, each contribute to only 10%, then you will get a flat Pareto. What you should do is, by occurrence, I couldn't do a prioritization. What else you could do? You could use cost as a factor. So you can come up with defects and the cost impact on business. You can collect data, you can also run a Pareto chart, and hopefully you will get either one or two. In that case, you can pick up the prioritized categories and then you would be able to move forward. Great. I hope a simple tool, but I think whatever we have discussed so far, the hands-on definitely would have helped you. What I want to end this session with is share some of the supply chain use cases with you. Okay, as I've told you, as a consultant, this is one of the prime tool. I use it for prioritization because it is relatively quick and gives a great direction for the project. I'm going to share few use cases within supply chain, like the most in manufacturing. If you want to talk about type of manufacturing defects and the contribution to the overall defects in that manufacturing process, right, could be a great use case if you take manufacturing as an example. Another important place where I would use this is cost benefit analysis, which there are abundant scenarios within supply chain. Before you you put up your implementation plan, you have 10 different things you can do. You can come up and say, if I do this, what would be the cost impact or a benefit? If I do these and this, what's the impact? You can actually put that into a data table and find out which gives you the kind of a best benefit out of the options what you're having. You can definitely use a Pareto chart to do that. Third one is types of supplier issues and its contribution to overall supplier rejection. So this is typically either it could be a manufacturing inbound process, that is typically an RM invert, or it could be a bought out item. You are going to take it from the supplier, you are doing some inbound quality check, picking up data of different issues faced from a supplier and what is its contribution to overall rejection. You can use a Pareto chart again to prioritize. So this could be a classical example, right? Assume you are doing a SMART goals for this quarter and there are 20 different supplier issues. Can you solve all 20 in one quarter or in 1 year? Not possible. And is it really make sense to solve everything? What if out of this 20, only 2 defects or 2 issues contribute for 90% of supplier rejections? Now you really can focus on just this 2 and you can bring the value and show that value to the management. The next one could be reasons for delay in deliveries, typically a logistics example, and its impact on overall on-time delivery, one of the key metrics in transportation, right? So you can again use an Pareto chart to do analysis on reasons for delay in deliveries versus the impact on the on-time delivery. You can also do types of expenses and contribution to the overall operating expenditure and facility. There are a lot of cost reduction projects people would be driving, right? In that case, you want to decide what should be my goal, which one I can chase and find out, right? This could be a great lever. Sometimes use this Pareto chart to set your goals itself, right? Sometimes boss will come and ask you, okay, give your targets for the next quarter. Rather than blindly giving him a target, indirectly a commitment, you can quickly collect this data, do a Pareto chart, understand which expenses you can really, there are some quick wins available, which has a maximum impact or a contribution. Use that to give your smart goals itself. Okay, so these are all some of the use cases, and I hope you enjoyed this video on the Pareto chart, and there is going to be a series of videos planned in more tools which are used in supply chain. So stay tuned. Thank you so much for watching this video today. Yeah, take care. Bye bye.